Hi everyone, welcome back to Java 1 for All. In this video, we are going to talk about another way we have to get the lock of a object. The name of the class we will be working with now is ReentrantLock. So basically, you can add here a lock that's from the package ConcurrencyLock. This is an interface, and the object is the ReentrantLock. Okay, so you can get the lock in two different ways, using the synchronized and using the reentrant lock. What's the difference? First, the synchronized is like just giving the responsibility to the JVM to handle everything. So for example, when you have synchronized, you know that if you access with multiple threads the same synchronized block, all the threads will be waiting like indefinitely. There is no way for you to tell the threads to just stop waiting. And the reentrant lock, it gives you some other options. The first one is that there is this ability to interrupt. The second one is you can give like a timeout, like say for example that I want to get that lock or try to get that lock for like 30 seconds. You have this try lock where you can give the time 30 seconds. So it will try to get, if it can't, it will just move on. So there are a couple differences more. So this is the first one. There is another one that's the fairness concept. You can pass here in the constructor of the reentrant lock the fairness. If you say true, it will try to give the lock to the thread that's waiting longer in the queue, but it's not, unfortunately, it's not guaranteed. So you saw the try lock and the ability to interrupt the thread while they are waiting for the lock. And there is also a convenient method that will list all the threads waiting for lock. So basically, I think one of the biggest advantages that we have is that you are manually handling the lock, which can be dangerous, and the ugliness that is going to add to your code, because if you acquire the lock, you have to make absolutely sure that you are unlocking that thread. For example, if you acquire the lock that you unlock, you can acquire a lock like this, lock.lock. When you do this, you are acquiring the lock. At this moment, if you never tell the thread unlock, just release this lock, that thread will hold that lock forever. And this is a big problem. So how do you handle, for example, if you have an exception in between these lines, and right here you try to unlock? Well, the way that we have is using try and finally. So every time you see someone using the reentrant lock, you will probably see the try finally somewhere. Because if you have an exception here, it's guaranteed that the finally block will be executed. So enough talk. Let's see how the try finally works in another example. Let's create here. Let me see. Reentrant lock test 01. So what we're going to do first, we are going to create a class. Let's call this class worker, and this will be a runnable. So same procedure, implement the run method, and now what are we going to do in this run? Let's imagine that we just want to print some information. So the first thing is when we create this worker, we are going to need two things. Name, what's the name of this worker, and then the reentrant lock. So I'm giving the object type here reentrant lock because that is this very nice method. For example, is held by current thread, and get queue length, for example, that's not available here in this lock interface. So let's use reentrant lock here. Okay, so we have both names in the reentrant lock. Now let's create a constructor. Both of them will be mandatory. And now let's get the lock. So we acquired the lock, and then try. Let's add catch interrupted exception, because I'm going to probably use the sleep somewhere. And then finally release the ReentrantLock. So let's just rename this to lock, Shift F6, lock, and select the constructor parameter. Better lock.unlock. Okay, now thread.sleep 2 seconds. Okay, we have been using system out print ln, but now we are going to use system out print f. So just change instead of south to south, and then this basically is a well, if you have any experience with C, this came from C. It will replace some meta characters. For example, if you put %s and separated by comma, you add the variables that you would like to replace this %s. So here I want the name. So if I add something here, for example, thread, and then %s, that will be replaced by this name, enter a critical session. And if I wanted another %s, I just need to pass another variable. Could be something, for example. So whatever you have after the first comma will be the attributes replacing the percentages. So for example, for numbers, integers, you would use %d as delta, and for double or float would be %f. But we are going to stick with %s and maybe d, and there is another one, %n, that will jump one line, because this one will not jump lines. Okay, so now I want to know the number of threads waiting. So %d, and here I will add ReentrantLock dot get queue length. So basically it gives an estimate number of threads waiting to acquire the lock, and %d threads waiting for the lock. Control D. Now the thread, and I will give a name here, the thread name %s is waiting, and the is going to wait 2 seconds. And then I'm giving thread names here, but actually this will be objects. Well, we can rename this to thread to object to make things easier. This one keeps thread, so object. And now continuing, let's say after the 2 seconds it finished. So the %s finished the session. Actually forgot to jump lines here and here and here. I just need a name. Printf. Cool. So let's start. Let's go back to the main method down here, psvm, and then new thread. Let's give a name here to this worker, new worker. I forgot to create here, final ReentrantLock, lock, new ReentrantLock, and then we give a name to this, A, and then we pass the ReentrantLock. That's this lock. We could give a name to this thread as well, but yeah, the name that we are using here is the name of the worker. We are trying to represent the thread. Start. Just add some more. We have B, C, D, E, F. Let's stop at G. Cool. Let's execute this. Control Shift F10. As you can see, object A entered the critical session, 6 threads waiting. So we have 7 threads here. That's, of course, 1 is executing, 6 is waiting. And then A finished, and then B, and then C, and then D, E, F, G. So looks like all of them were in order. Okay, so let's see if we give the fairness here as true. The order of the threads acquired the lock will change. So Control Shift F10. A. After A we got B. Yeah, looks like well, we got D instead of C. And C, yeah, got all the way down. And then G. Yeah, I was hoping G would be the maybe one of the ones after maybe C, but yeah, it didn't change that much. If we execute again, A, B, then C. Now looks like this time no fairness for you guys. As you can see, it's not guaranteed. But it's nice that we know how many threads are waiting, and we have the lock and we are unlocking. Of course, you can only unlock if you have the lock. For example, if you try to acquire the lock, now things will get very interesting. First, this one, if you give, let's say, just wait for 2 seconds and then give up. Boolean B. Percent S. We don't know for sure who acquired the lock. Even if I do this, for example, percentage S acquired the lock, and then name. Well, I don't know if the ones here are the ones with the lock. How do we know who got the lock? If lock dot is held by current thread, then I know for sure that this one has the lock. Percentage N. Now we are going to get an exception here because we are always trying to unlock, but there are some threads that don't have the lock because we are just trying. Let's see. Okay, so where is my exception? There you go. Illegal monetary state exception because we are trying to unlock something that we don't have the lock. So basically this should be here as well. Control Shift F10. So the difference between the first one is that now they try to acquire the lock. After 2 seconds, they just give up. So we have here A acquired the lock, and then A entered the critical session, and then we have 6 threads waiting for the lock. But we are waiting for 2 seconds, and then object A is waiting. When it finished, D came back here to the critical session, but well, D does not have the lock anymore. So as you can see, it goes all the way. There is no threads waiting for the lock, and all of them finish the session. So this is the ReentrantLock. We can definitely improve this code, but let's continue with more topics about this ReentrantLock in the next video. So see you there. Bye.